This is a demonstration of basic simple G-code programming using lines and arcs. I'm using the CNC Easy milling simulator, which I got through school. And here you can see the verification screen. And what we're going to do is we're going to single step this program which I made. And down here you can see the code being executed. And we'll show you the entire code before we execute it. This is it. And we're going to single step it so you can see each line of code as it's executed. We'll look down here. The percent sign is a flag indicating that the controller should start the program. Here we see the program number beginning with the letter O. Here we'll see a prerequisite block, G90, which is absolute programming, G80, which is clear any residual can cycles, G40, which is to cancel any width offsets, G17, which means we will be using the XY plane. Any comments can be placed in parentheses and will not be executed by the controller. Here we're going to be calling tool 11. In the registry I had previously designated the register values for tool 11, which is primarily the offset, half the distance of the diameter of the tool should be the radius, and any H factor, which would be the height factor, would be placed in another bank in the registry. Now over here you can see that we've changed to a tool 11, which is a 1/2 inch end mill. We're going to start it clockwise at 1528 RPM, which is a factor of 200 surface feet per minute, 3.82 times 200 divided by the 1/2 inch end mill will give you 1528. And now we're going to rapid movement, which is G0, G54, which is the 0 which I set at the lower left hand corner of this piece of stock, which is 6 inches by 5 inches. And we're going to traverse rapidly back in this direction, 3/4 inch X, 3/4 inch Y, which will be away from the piece. It's off the screen so you can't see it. Now we're going to pick up the height offset, which is G43, and we're going to move down to 3 inches, which won't be visible on the screen. And we're going to be using a height register offset of 11. That's tool 11, which was preset. Now we will actuate the current coolant, which is M8. And now we're going to rapid traverse to 100 thousandths above the piece. And now we're going to feed down a 1/2 inch at approximately 6 inches per minute. Now we're going to move to the 0, which is X0, Y0 at the feed rate designated. Now we will traverse in the X direction 5 inches. This is a 6 inch piece of stock. Should stop about right here. And now we're going to move up in the Y position 1.5 inches. Since this is a 5 inch piece of stock, it should stop about here. And now we're going to execute a G3, which is a counterclockwise arc movement. Now you can see we've designated the endpoint of the arc, which is X 6 inches by Y 2.5 inches. Since we're using the I and J incremental center of arc, it should stop about here. Now we're going to complete the arc, which will be a 180-degree arc. Sometimes it's a good idea to program in quadrants, as some controllers may not recognize more than 1/4 of the circle as a designation. You can see we've designated the endpoint as 5 inches by 3.5 in the Y direction. The center of arc is -1 inch, and J is at the same plane. Now we're going to feed the same feed rate, since it is modal, to 5 inches in the Y position, and that would be up here. We're going to go to the X positions 0, which will be over here, and we'll come back down to the Y0 position, which will be here. Now you can see I've programmed the tool to move 3/4 of an inch away from the piece, which will come out to be a tangent angle. Since the X and Y position are both in the same block, we'll move the tool away this way. Now you can see I'm going to lift the tool up at a rapid pace to the Z3 parameter, which is above the piece. And now you can see we've turned off the coolant. And now you can see that we're going to home the machine and stop the spindle with an M5. We're calling the tool again. Let's move 5 inches above the piece. That should be the end of the program.